Okay guys, so we're going to talk about special right triangles. The big deal about special right triangles is this, okay? If you know one side of a right triangle, you can find the rest, the other sides, you can find other sides without the use of SOHCAHTOA. So that's the only thing that's different about these types of triangles is that you can, I would say they're kind of like using shortcuts without having to use sine, cosine, or tangent. And so we're just going to do two, focus on two of them for this, okay? The first kind is called a 45-45. Okay, and here's what it looks like. So this is the important part, okay? So write this down. 90 degrees here, 45. Remember, both of these have to add up to 90. So that has to be 45, 45. So since these two angles are the same, just common sense would tell us these two sides have to also measure the same, okay? And so we can call that length x. Again, it has to be the same length. And then if you do the Pythagorean theorem, then we know the hypotenuse would equal to this, okay? So this is like the formula, I guess you could think of, for a 45 degree angle. And so now I'm just going to do a few examples with you so you can see how this works, okay? I'll do one right here so I can see this next to it. I don't have any students right now, so I won't be asking any questions. But just want to ask you to pause the video so you can go try it on your own, try to do it. That way you could still benefit like you would do in regular class. Okay, so here we go. You don't have to do this because I have the baby on the way tomorrow, and so I won't be here to teach you guys. Okay, so let's say this side is 3, and then again this is 45 degrees, 45 degrees. I need to tell you something really important about this. These are shortcuts, okay? They're designed so that you could do it quicker if you recognize that it's a 45 degree triangle. But what I want you to know is that you don't have to do them this way. You can do them with SOHCAHTOA and they work just fine. So if you forget how to use these or they don't make much sense to you, again, you can just go and use SOHCAHTOA like you usually do. Okay, but anyway, let me show you how it works. So again, since this side is 3, we know this side is 3, okay? Because those two sides have to be the same. And this side, so remember this is like x equals 3, x equals 3. And this side is x square root of 2. So that means I know what x is, so x is 3. So the hypotenuse is 3 square root of 2, because x is 3. And that's all there's to it. Again, this is faster than it would have taken me to use SOHCAHTOA, and I didn't need a calculator to do this. And that's what makes special right triangles special, because you can do them quick, okay? So this is how we take questions from you guys, but you're not here. So let's go on to number 2. Example 2. Okay, example 2. And this one looks like this. So again, all these have to be 45s, 45s. 45 degrees, 45 degrees. And then let's say the hypotenuse is 12. This one's a little more tricky, but here's how it works. Okay, if you want to go ahead and try it, pause the video and try it real quick just to see what you can come up with. But here's how I would break it down. Okay, so we know this side, let me use a different color here. This side has to be x, this side has to be x, and this side is x square root of 2. Right? That's what it has to equal. And when you look at it, you're like, well, there's no square root of 2, right? So here's what I would suggest you set up. I would say x equals what? And then x square root of 2 is equal to what? So in this case, we know the hypotenuse is 12. So we know that this x square root of 2 has to equal 12. So you kind of work backwards, because once you set it up this way, then I can solve this equation for x, right? So I can divide both sides by square root of 2. And the reason I would want to solve it for x is because then that would be my other two sides, okay? So this cancels with my square root of 2's. Okay, but as you see, we talked about this before. I think it's 4.1. It's called fixing the radical on the bottom. You can never have a radical like this on the bottom, so you have to fix it. And you can do that by multiplying the top and the bottom by the same radical. I guess I'll work to this side here. And what happens here is those square root times the square root cancels the square root, so that just leaves you with 2. And then this would be 12 square root of 2. And then hopefully you see that 12 and 2 also reduce. 2 goes into 12 6 times. So my final answer here for x is x equals 6 square root of 2. Okay, this is called an exact answer. I know we've talked about that a lot of times, because that includes all the decimals that are necessary. And this is really important because, like on the test, on the review, you can have an answer like this, where if you use SOHCAHTOA, if you use sine, cosine, or tangent, you're not going to get this type of answer. You're going to get the decimal. So I'll go ahead and type it in. 6 times square root of 2. And so that's approximate 8.5 if I round to the nearest tenth. And that's the kind of answer you would get if you use SOHCAHTOA on your calculator anyway. So you need to know that if you use SOHCAHTOA and you have 8.5 and you see this answer on the test, you can just put this on the calculator and see what that approximate answer is. Okay. So anyways, this is 8.5, this is 8.5. Okay. If you do have questions, you can email me if I'm in the hospital, but hopefully it makes sense to you. Let's try one more example, guys, of this, and then I think you'll be good. Example 3 for 45 45s. Okay. So again, 45-degree angle. And again, I know I sound, this is repetitive, me saying this, but the advantage of this is that you can do them faster once you get the hang of it, and you don't need a calculator. Okay, so I would pause the video and go try this one just to see if you're doing it right. While I take a sip of my morning coffee. Okay, so here we go. Okay, so again, I know the sides have to equal x, and I know that the hypotenuse, the longest side, has to equal x square root of 2. And this one's actually super easy because, well, look, it's already like that. This equals this. And this already has the square root of 2 part, so x equals 6. So this one was super simple. Okay. And I think that's all there's to them. Again, if you I need to stress to you that if you use SOHCAHTOA, you would get an approximate answer instead of 6 square root of 2, but both of those sides would be 6. If you didn't catch that, like if you didn't make this connection, how is that equal? You can keep on solving this. I'll go ahead and solve it so you can see. Square root of 2 equals 6 square root of 2. So I need the x by itself, so I divide both sides by square root of 2. And that's how x equals 6. All right, so I'm going to separate the video here.